In this video, we will look at using data in Connect Data Services. We will start with an introduction to streams, assets, and to data types. To start, let's see how data is stored and structured in Connect Data Services. All sequential data in Connect Data Services is stored within streams. These streams are defined by their stream types, which act as a sort of blueprint to define what properties should be on the stream. Streams can be of various types. You can also have multiple streams per type, and these streams can then be contextualized using assets. Assets themselves do not contain any data, but they reference the underlying streams and provide a useful container for users to get a better understanding of what their streams represent. Additionally, assets can be based off of an asset type, though that is optional as they also do not require a type. So, let's dig a little deeper and take a look at each of those components. We will start with stream types, and these define how data is structured in a stream. They are immutable after creation, meaning you cannot change them after they've been created. They have properties, which are simple atomic types, ints, floats, etc., with optional units of measure. In this block, you can see that there are a few example properties. We have one for timestamp, which has an SDS type of date time. We have another property, which is a value, and it has a double type. And lastly, we have quality, which is a nullable int32 type. As you'll notice, none of these have units of measure, but that would be optional. Say we know that this value is always going to be a certain UOM. We can define that here. And as we'll see later, we could also define that on the created stream. Types also define how data is read from a stream. They have a key, which is the primary index that constitutes an ordered unique identity. In this case, we have the timestamp as our key, and types can be referenced by other types. Next, we'll take a look at streams. So streams reference a type. As we can see, they have a type ID field. They can have tags and metadata, which are useful static information about the stream. Metadata is representing a key value pair, so for site, it might be SLTC. And then tags, which are just a simple value, which could be something like pi to ADH. These just give you an easier way to search your streams and find useful information about them. On our streams, we have the option to define secondary indexes. And we also can define property overrides that can be used to override units of measure, or how data is read. For example, changing the interpolation mode of the stream. Next, we'll take a look at assets. Assets allow a user to model assets, equipment, or processes in Connect Data Services. For asset properties, the two we see here reference streams and stream data. So, in the case of this motor RPM property, we can see that it references the my first stream. And for motor temperature, we can see it references my second stream. So no data is duplicated, we're just referencing those underlying streams. Additionally, they have static information which we call metadata. So this is similar to our streams, where we have a key value pair. We can use the same example, where we would have the site of the asset and corresponding value. And as mentioned before, assets can optionally reference an asset type, which we can see using this asset type ID. And lastly, let's quickly touch on asset types, and how these are used to define assets of similar types. It's not a strict definition, as assets can have additional properties that are not on their asset type, which differs from the way stream types work. And the main benefit of asset types is that they are used for searching, as they can categorize your assets, and they're used for other features within our portal, along with other visualization tools. Next, let's look at documentation. The information shown in this video came from docs.aveva.com. Let's open the Connect Data Services area. Let's navigate to Connect Data Services, Developer Documentation. In the contents, we have the Developer Guide and the API Reference Guide. If we take a look at the Developer Guide, there are sections for many of the features within Connect Data Services. In the API Reference Guide, we can see the different routes, how to interact with them and what they return. For example, if we go to Sequential Data Store, and then select Streams. Here we can see how to list our streams and our tenants. We can see how to get a specific stream, what we need to put into our requests and what parameters we have available, and what response we can expect back, along with the response body. Let's finish with a demonstration in Connect Data Services. Now that we've seen how data is stored and contextualized in Connect Data Services, let's see all of this in action. Here you can see we're in Data Services in the AVEVA Events namespace. The first thing we're going to do is go to Data Management and click Sequential Data Store and switch to the Types view. We're going to review a few different types to start off with. We're going to start with the basics and search for the double type. As you can see, we have this time index double type. If we click on it, we see that this type is very simple. It only has two properties, a timestamp property, which is a date time, and a value property, which is a double type. We can see the other base information here, such as its ID, its name, and optional description along with an optional base type. Next, let's take a look at a slightly more complex type. We will search for air. And we can see that we have this air quality sensor type. And if we click on it, we've got 13 different properties here, so a lot more complex. And each of these corresponds with a different measurement type of the air quality sensor. Lastly, we'll take a look at another common type, which is one of our pi types. So, we can take a look at pi float 64. This type is created automatically by the Pi to Data Services agent to represent the data stored within our on-premises Pi tags. We can see that this has a timestamp and a value, but it also has additional quality information, such as its questionable flag. It's substituted and has other information that you would expect to find on a Pi tag. Now that we've covered stream types, let's take a look at some of the streams defined by these. We'll start with Pi float 64, click on the ellipses in the top right and get type streams. We can see the different streams defined and based off of that type. So, starting with the first one in the list, we can see that our stream has an ID, a name, and it has a reference type. Additionally, we have our static information such as metadata and tags. We can see we have a tag which is one of the projects this is being used in, along with stream metadata which are our key value pairs. So we have things like our engineering units, our point ID, this is information from the tag definition on our Pi system. And if we want to see data on the stream, we can do that just by clicking View Data. And now we're looking at the last 100 events. Now that we've looked at streams and types, let's go to Assets. So, go to Visualization and Asset Explorer. And we'll take a look at these wind turbine assets. Let's start here with AE01. On our asset, we see that we have static information in the form of metadata. So this is a key value pair. For each of these, we can also have a unit of measure. For our dynamic data, we have properties. And we can see that we have a whole list of different properties on this asset. If we select some of these, we can take a look at them on the trend shown below. Additionally, assets can have an optional status, so this is where we correspond to one of those properties with the status of the asset. So for example, if one of those properties indicates whether our asset is in a good, warning or bad state, we can map out those values and take a look at that information over time. Let's look at the last 8 hours, but we could also expand that to the last 30 days. We can see there's some instances where this wind turbine has had gearbox vibration issues. Going back to properties, as we mentioned earlier, assets don't actually contain data themselves, but they reference underlying streams. And if we click this Edit Asset icon, we can see that these properties are referencing streams. One last notable feature of these Windtopia wind turbine assets is that they're based off of this asset type, called GE wind turbine. If we select it, we see the expected properties for this asset listed below, along with metadata. So when we create new instances of this wind turbine asset type, it will have the metadata pre-filled out and we can modify it as needed. And we can map these properties to the corresponding streams. Also, we can define a status on this type, so that all created assets of this type will also have this status mapping. So, this now concludes our demonstration of how sequential data is stored and contextualized within Connect Data Services.